Alright, section 5.5, we're dealing with more logarithms. Let's talk about a little bit of review from algebra. 2 to the third is 8. That's called exponential form, where you write a base with an exponent. Logarithmic form is taking that base and putting it as the base of a log. The answer goes here, and it equals the exponent. So log base 2 of 8 equals 3 is really the same thing as this, just written in logarithmic form. So if we start with log base x of 8 equals 3, and we're asked to solve for x, the easiest way to solve that, if x is your base, is maybe to look at writing it in exponential form. So x is your base, 3 is the exponent, and it equals 8. So we want to get rid of the log by writing it in exponential form. And then we want to take the cubed root to solve that. And x equals the cubed root of 8, which is 2. Alright, so looking at another example, if we want to solve for x, there, and we have log base 4 of 1 over 64 equals x. So 1 over 64 is the answer. 4 to the x would be 1 over 64. So rewrite the log equation in exponential form. So 4 to the x equals 1 over 64. 4 is the base, x is the exponent, and this is the answer. And let's try to write 64 using the same base as 4. 64 can be written as 4 to what power? It's 4 to the third. So we're just rewriting 64 as something that has a power that matches, or a base that matches this 4. And again, rewriting some more, 1 over 4 to the third can be written as 4 to the negative third. Because negative exponents mean you should have done the reciprocal, so we're using that property backwards and going from the reciprocal to 4 to the negative third. And now you can see these have the same base, right? So the exponents must be equal to each other if the bases are the same. So x would be negative 3. So that's one way to solve it. You can also solve this equation by using the change of base theorem, which you learned in algebra. If you have the log of x base b, you can change that to the log of x base any base divided by the log of b of any base. And the most common base we use is 10, just because that's our common log. So log of x base b is this log of x divided by the log of b, using whatever new base you want. So that would be, if we go back to this problem, log of 1 over 64, log of 1 over 64 divided by log of 4. And that, we didn't write the base, so when you don't write the base, you assume it's base 10. Your calculator automatically uses base 10. So if you type in log of 1 over 64 and divide that answer by log of 4, you will get negative 3. So in this form, you can't use your calculator, but in this form you can. Your calculator can do those logs for you. You could also do log base e, which means you could do natural log of 1 over 64 divided by natural log of 4, changing the base to e. As long as they have the same base, you can use this change of base theorem. These bases just have to be the same, and e and 10 are the most common ones we use. Alright, so remember the derivative of e to the x is e to the x? Well, here's some more stuff to memorize. We're going to be talking about bases other than e. So the derivative of a to the x is not just a to the x, but it's also times the natural log of a. So the derivative of a to the x is the natural log of a, which is usually a constant, always a constant, times a to the x. A is a positive real number, but not 1. Okay? And then the partner to that is if we have the derivative of a to the u. So u is some function of x. So that exponent up there is not just x, it's like x squared or 3x plus 1 or some kind of function involving x. So the derivative of a to the u is the natural log of a times a to the u, kind of like what we had over here, but then also times the derivative of that exponent. Okay? Oops, sorry about that. And then the derivative of a regular log base a of x is 1 over natural log of a times x. And the derivative of log base a of u, so u is a whole function, is 1 over the natural log of a times u, and then times the derivative of that function. So these two are if x is just plain x, but this is if you have a function of x. Now let's think about why that works with e to the x, because e is a number. E is a number that's a positive real number. So how does that work with this formula, the derivative of a to the x? Because let's say our a was our e. So what if we were doing this formula using the derivative of e to the x? It would be the natural log of e times e to the x. Well, what's the natural log of e? It's just 1. So we have 1 times e to the x, which equals e to the x. So that's really not a new formula, just the old formula, or just the same formula used with two different things. So let's do an example. If we have g of x equals 5 to the negative x over 2, so this is like our a to the u times sine of a different u, and we're trying to find g prime. So we've got a product, and within our product we're going to have to use our new rule. So this is u and this is v. If u is 5 to the negative x over 2, then the derivative of u, or u prime, some people are using that. The new rule we just learned is it's the natural log of 5 times a to the u, and then times the derivative of that negative x over 2, which is negative 1/2. So going back to look at that rule, it's this one right here. It's the natural log of the base times the base to the u, so that original function, and then times the derivative of that u. And then v, I'm going to move the v over here. Sorry, let's undo that. v is sine of 2x. So the derivative of v is the derivative of the outside, which is cosine 2x, times the derivative of the inside, which is 2. So we have 2 times cosine x. So product rule says u times v prime plus v times u prime. Can we simplify anything? Well, not really. We can't multiply these two together because they have different exponents. We can't multiply a negative 1/2 into anything. So I guess I would write 2 times 5 to the negative x over 2 times cosine 2x minus natural log of 5 over 2, because those are the constants, natural log of 5 and negative 1/2, times 5 to the negative x over 2 times sine of 2x. The back of the book might factor out 5 to the x minus to the negative x over 2, but I don't know. So that's your final answer. It looks ugly, but that's how you do it. How about this one? If we have to find the derivative of h, and h has all these logs, right? Can we use the log properties to simplify this? Or change a base theorem, or what should we do? We can definitely rewrite this using the change of base, or not the change of base, the log properties. So we have log base 3 of x times the square root of x minus 1 minus log base 3 of 2. Now all the x's are gone here, so this is just a constant. We can break it up again. We have log base 3 of x plus log of the square root of x minus 1. And then we still have minus log base 3 of 2. So broke that up, and then this is x minus 1 to the 1/2, so we can put that 1/2 power out in front. Sorry, I forgot to write the base 3. If you don't write a base, it's assumed it's a 10. So 1/2 out here, log base 3 of x minus 1 minus log base 3 of 2. Right now we can take the derivative using our derivative property, or derivative rule that we just learned. This rule right here or this rule right here. So it's 1 over natural log of a times u and then times the derivative of u. So 1 over natural log of a times u and then times the derivative of u would just be 1. Plus 1 over 2 times 1 over natural log of a times u and then times the derivative of u, which is just 1. And then here, the derivative of a constant is just 0. So we have 1 over x times the natural log of 3 plus 1 over 2 times the natural log of 3 times x minus 1. That's your final answer. We can also use logarithmic differentiation. So remember what that is you take the natural log of both sides so that you can use log properties to simplify. On the right side, that power can go out here, so we'll have x minus 1 times the natural log of x. So now we have a product. Take the derivative of both sides. This is y prime over y. And here we've got u and v. So u is x minus 1, u prime is 1. V is natural log of x, v prime is 1 over x. So our product rule says we do u times v prime plus u prime times v. Distributing these two together, we get 1 minus 1 over x plus natural log of x. But that's not what y prime is equal to, that's what y prime over y is equal to. So multiply both sides by y. And replace y with x to the x minus 1. And if you distribute that, it's not going to be much simpler, so you might as well leave it like that. There's your homework, page 368. A few choice problems for you.